All right. So again, just for those that are new to this, very quickly, a little bit about Archimedes. We're a software engineering guild, and we basically sort of live by three principles as a guild. The first is this concept of belonging in an ever-changing world. We live in a time where by the time you are about my age, which is early 40s, you basically have been through potentially half a dozen or so companies in your career already. And Archimedes is in some sense a place that you can belong to that sort of goes beyond the temporal association you might have with a company. And that's something that I found very valuable after I left Accenture, where yes, we do have an alumni network and things like that, but it's really extremely sporadic, where in maybe once every 3 or 4 years we might interact with it. So Archimedes provides more of a sort of an umbrella organization that you can belong to beyond the company that you work for, especially as it relates to software engineering. The second part of Archimedes is around enabling people within the guild to be able to grow and to excel at the skills that they choose to focus on. And then the third part of it is to understand, to provide members in the guild opportunities to go out and earn income through a variety of different revenue streams in a way that doesn't that's not exploitative. That's not from the point of view of wage arbitrage and things like that. Essentially, we have guild members that work through Archimedes around the world, and they're valued for what they are good at and not for their location as such. In terms of just within the guild, we have various bands. So the guild is very similar to guilds as they originally were back in pre-industrial era Europe, I guess, where you had 3 levels: at apprentice, master, grandmaster level. We have a little bit more granularity here, from apprentice through to practitioner, then coder, expert, and guru. And you could be an expert in a certain skill and even an apprentice in a different skill. So it's not hard and fast where you're an expert, and you're an expert across the board in everything. And our guild members tend to be everywhere. We basically have just naturally had a lot of focus, that a lot of folks that have joined the guild from Africa, from South Asia, specifically India, as well as North America, specifically the US. We also have guild members in other parts of the world, and kind of focused a little bit over the next couple of years into South America, Europe, and Southeast Asia and Australia. And companies can access the guild through a variety of different ways. I'm not going to go into the details of this, but essentially, they, depending on what kind of expertise they need and in what form, there are different ways in which they can access the guild members. So that's high level about Archimedes. In terms of the masterminds, we've been doing the masterminds for a little bit over a year now. We've had masterminds in a variety of different sort of advanced engineering topics, ranging from micro front ends to graph databases. We've done topics on blockchain. Our last event was on ML ops. Our next event's most probably going to be on Solidity and blockchain as well. Not sure at this point yet, but I think from our perspective, we try to through the mastermind provide a sprinkling of knowledge in areas that are of interest to engineers, and we are going to develop this in a more in sort of a more work stream like manner going forward. We're not there yet, but we are going to get there at some point, where we'll have deep dives into certain subject areas in the coming months and years. You can follow us on YouTube. You can watch the videos there. You can also follow us on our LinkedIn channel, and all the events that we post are on LinkedIn. So anytime there's a new event, you'll be informed through that. Today's event specifically is on WASM, and I think the intersect between Rust and WASM and building reactive apps. I think from my perspective, the interest lies in the idea that you can build really high performing and data heavy applications on the web using the combination of Rust and WASM. And I heard Joel present the same subject to some degree at I think it was a Denver Tech Confluence that is run on a monthly basis as well. And I found the topic really interesting. Started doing a bit of research myself, and I'm even more excited to hear from Joe. Joe's a senior software engineer. He's held a variety of different positions, but I'm sure he'll do a more thorough intro of himself as he gets into the topic. But really excited to have Joe and have him talk us through today's topic. So Joe, hand it over to you. I'll stop my screen share, and feel free to drive things.
Sure. Yeah, thanks so much, Static, for inviting me. Thanks for everybody for showing up. Hopefully we'll have a little fun today. Do feel free to interrupt me at any time. I like these presentations to turn into conversations. If there's, if you've got perhaps doubts, or you're not sure you understand what I am talking about, I certainly want to know that. Or if you just have questions of any kind, I'm happy to answer those during the presentation, and of course we'll have time at the end as well. So let me go ahead and share here. Can everybody see the title here?
Yes.
Great. Okay, yeah, like Sadik said, we're going to talk today a little bit about reactive web apps with Rust and WebAssembly. We'll go through some terminology in case you're not familiar with some of these words that you see on the screen. So let's get started here. So first, a little bit about me. I'm located in Denver, Colorado in the US. Good morning to those of you in my neck of the woods. Good evening and afternoon to the rest of you. I've been doing a mix of software development and software architecture design for the past 19 years or so. Most of that work has been in the real-time communication space. So think of the technologies that are underlying this Zoom call right here. I actually worked at a company called ReadyTalk for 12 years, which is it's since been bought by PGI, which I believe has now been bought by another company. I'm not sure what. I haven't really traced its evolution since I left, but they were and still are a competitor to Zoom. Of course, Zoom has essentially eaten everybody's lunch in that space, and with good reason. They've perfected a lot of things that are difficult to perfect when it comes to real-time communications over unreliable networks. My role at ReadyTalk and then at Mersive after I left ReadyTalk has tended to be focused on reliability and efficiency / performance with regards to real-time communications. I've dabbled in a lot of things, including UI development to some extent, although I wouldn't say I'm an expert by any means. I've done back-end work, server-side distributed systems, a lot of network optimization, a lot of graphics optimization, that sort of thing. And my tools during all this were primarily C++ and Java. Learned Java back when it first came out in the mid 90s, and C++ of course has been around for quite a while as well. But lately I've been probably the last 4 years I've been primarily implementing things in Rust. I introduced that language to my team at Mersive about halfway through my tenure there, with mixed success. I won't go into that too much. There were a lot of people there that were very diehard C++ fans and weren't really interested in learning anything else. Others were interested in learning, but of course, transitioning from one language to another is not always easy and doesn't even always make sense. So we had mixed success with that, but did have some successes, and I'll allude to that later in this talk. I think that's all I want to say about my background. Feel free to ask questions if you want to learn more, but we'll move right into the content here. So the overall agenda here is we're going to go through some terminology. I'm sure you guys all have very different backgrounds. Maybe some of you are not necessarily even programmers here, so I want to make sure we get our terminology straight before we go into depth here. I do want to talk a little bit about why I chose Rust and what might guide you in choosing a new language, or when solving a new problem, or perhaps deciding to stick with what you know. Then we'll talk a little bit about single page app libraries and frameworks and tools for Rust. If you do have a front end background, a lot of this will sound familiar. Just like in the JavaScript world, there are a lot of frameworks out there. It seems like everybody's written their own. We'll just look at a few of them, the ones that I'm familiar with, and talk about the differences between them. And then I'll finally introduce a little hobby project that I used as sort of a testing ground for sort of dip my toe in the water, so to speak, with WebAssembly in particular in web browsers. And despite the name, by the way, WebAssembly is not always necessarily about web browsers. It's actually found use in a lot of different spaces, both server and client side. So first, terminology. So reactive web apps, just a whirlwind tour. You may have heard the terms Web 1.0 and Web 2.0 and now Web 3. I'm sure when you guys talk about Solidity and blockchain, Web 3 will come up in some form. But briefly, Web 1 was about generating websites. Either websites were just completely static HTML and you just uploaded a new version to the server to be served up, or if you were creating a web application, something interactive, you would implement it in something like PHP, or more recently Ruby on Rails, or back in the day, Perl and CGI scripts. But what they all have in common is you generate the HTML dynamically on the server and then load it or allow the web browser to load it. And then each time the user wants to interact with that web application, it sends a new request up to the server and the whole page gets refreshed, essentially. So if you're paging back and forth in a shopping cart app or something like that. Web 2.0 is more about single page applications, HTML generated in the browser, traditionally via JavaScript, and any interactions the user has with the page could be completely isolated to the web browser, or may involve some sort of RESTful communication back up to the server, but which do not necessarily necessitate a refresh of the whole page. Perhaps just part of the page, or you'd retrieve new data and use that data to update some section of the page, some part of the UI that you're rendering. And then perhaps the most popular option these days for robust enterprise-ready web applications is a hybrid model, which gives you a bit of the best of both worlds. You generate some HTML on the server, so it loads very quickly. And then perhaps in the background, you download a JavaScript bundle that will add some dynamic elements to that web app. And then reactive programming has definitely been a popular concept. In fact, React, the web framework, is named after it. In summary, it's a declarative programming paradigm concerned with data streams and the propagation of change. And so it's this idea that you have pieces of data in your application, your model, that are evolving, that are changing, and you have listeners to those changes that are concerned with updating the UI, and perhaps also concerned with propagating those changes off to a server somewhere, etc. So you have mutating data, and listeners to that data are pretty much the core properties of this paradigm. And so, like I said, examples of that are React, Angular, Vue, Solid, Elm, pretty much any web framework out there that you may have come across, and there certainly are many, are based on some variation of reactive programming. Some of them are more functional reactive, some of them are more imperative, but they all have share this sort of reactive core. So WebAssembly, this is something, I'm not sure how old it is now. I know I was talking with people about it, 10 years ago. I should probably look it up. So it's at least 10 years old. And it's, but it's probably very new to some people. It hasn't really taken over the mainstream, but it has found its niches. In summary, it's a platform and language independent binary format for executable code. If you've been around for a while, there have been other attempts at this. Java bytecode, for example, is arguably these days both platform and language independent, in that there's multiple languages that can run on the JVM, such as Scala and Kotlin and Clojure and that sort of thing. But it's still fundamentally tied to a Java-like language under the hood, and which implies a certain degree of static typing and garbage collection and whatnot. Whereas WebAssembly doesn't currently involve garbage collection. It's actually a proposed, or it's an experimental extension that may actually arrive in the future. But for right now, it's mainly intended for lower level languages like Rust and C++ and C. And so the idea here is to be able to run systems code like game engines, or very intensive CPU or GPU intensive operations that traditionally aren't well suited to JavaScript or an interpreted language. Of course, modern JavaScript engines are very efficient and very intelligent, and can be very effective performance-wise, but they still potentially leave something to be desired from a consistency of performance that is definitely needed for a topic that's close to my heart, which is real-time communications, audio, video encoding, decoding, that sort of thing. That's where WebAssembly tends to shine. But it's not just, oh yeah, go ahead.
Sorry, Joel, just very quick question. I've been trying to get a sense of what some of the metaverse frameworks on the web are written in, particularly things like Zrun. I mean, I don't know, it's just hard for me. Like, I guess you could use JavaScript for something like that with the right libraries, but have you started to see WebAssembly in that context much at all?
That's not an area that I know a lot about, so I'm going to have to give you somewhat of a vague answer, which is, keep in mind that web browsers do have a lot of already built-in, a lot of very efficient built-in technologies written in probably C++. If you think of Chromium or Firefox or Safari, they already have media encoders and decoders for the H.264 video codec, for example, or VP8, and then there's WebGL for rendering 3D graphics efficiently, and so there's no need necessarily to implement your application code, basically your business logic in WebAssembly to take advantage of those technologies, the built-in video encoding or decoding. So I would say I would not be surprised if some of those, those technologies are still based on JavaScript or TypeScript or something more traditional, more traditional web languages. And then they effectively call down into the built-in web browser stuff implemented in C++ and possibly CUDA for interacting with the GPU, for accelerating basically the number heavy and the sort of computationally heavy tasks. Does that kind of make sense?
Yeah, no, that makes sense. That's what I assumed as well, to some degree, that like things like WebGL already exist, so they probably take advantage of those things. But nonetheless, I think as they get more advanced, and much more interactive, data heavy, I can see some cases where it starts, something like this could be very, very useful,
Yeah, and extending that idea, what got me excited about it in the beginning was the idea that there's constant innovation in, say, media codecs. This is something I spent a lot of time thinking about. You probably heard of H.265, which is or at least that was one. I think that's maybe been renamed now, but H.265 is the successor to H.264. And there's been and there's AV1, which is kind of the latest Google-sponsored standard for video codecs. These things aren't necessarily available on all web browsers. Like if you go to caniuse.com and ask, can I use like the latest media codec? Well, it depends on which version of which browser you're using. The potential with WASM, especially when you add in auto vectorization and access to general purpose GPU libraries and so on, is that you could actually on the fly add support for a new media codec to your application without worrying about whether that support was built into the browser. So that's what's really exciting to me. Or if you have a new advanced physics engine for your 3D game, and it's, obviously not every web browser is going to have a physics engine that's necessarily suitable for your 3D game. The potential that you could load that as a library, a WebAssembly library, and not worry about necessarily which browser the user is running. That's the real power I think we're talking about here.
No, it makes sense.
And then I think I already said this, but you're also seeing this on the server side. You're seeing this in the cryptocurrency world and blockchain world, using WebAssembly as a transaction language, for example. Also for serverless kind of functions as a service, to get those cold start times down to a minimum, you really want the lightest weight runtime or even no runtime underlying your language. And so you potentially just get these cold start and hot start times that are, minimize latency and maximize, performance and throughput. So any domain, to sum up, where you need to maximize portability, performance, memory efficiency, save cost in terms of your cloud computing bill, WebAssembly potentially can help you out. And just one other thought on this topic. I've spoken with a few people, including one of the founders of Docker, the Docker organization, and this is actually a pretty public quote. You can look for it. He was basically saying if WebAssembly had existed when they first created Docker, they probably wouldn't have created Docker. They probably would have gone down the road of, hey, instead of shipping containers everywhere, you should ship a WebAssembly essentially binary, which can then be run in an, and have the advantages of architecture agnosticism. It's not going to be x86 specific or Intel specific. It could be, could run just as well on ARM. So that's part of the vision here, is that WebAssembly could potentially be the successor to Docker style containers, which is an interesting thought. Okay, Rust, a programming language that has come on the scene probably in the last 10, 15 years. In a nutshell, it's a language, a systems programming language that is intended to give you fine-grained and predictable control of that you would expect from a low-level language like C or C++, but without the pitfalls, security-wise and debugging-wise, that we C and C++ programmers have learned to be wary of. It uses a type system and static analysis to prove that programs are free of certain classes of errors, in particular the errors that are most insidious in programs written in C++ and C. These memory errors, these buffer overflow errors, if you've heard of them, use after free errors. These terms should strike fear into you if you've been programming for a while in C and C++. They're very difficult to debug. It's very difficult to using statistical methods, such as fuzzers and tools like Valgrind, to determine whether those bugs exist in your code base, and so those bugs can make it out to the user and strike at the worst possible time. It also protects against data races, which is a very, I think, a very important point. And we commonly think of higher level languages like Java and Go and I don't know, name your favorite higher level language as being essentially memory safe, but that doesn't necessarily include data races. And certainly I've written plenty of Java code that had subtle data races where threads were concurrently accessing the same item of data. And it's one of those things, 99% of the time it'll work fine, but then it's in production and you'll hit a corner case and things blow up spectacularly. And not only that, but they blow up in a way that's hard to reproduce. And thus you spend a lot of cycles trying to debug it. And I throughout my career, I got very good at it, but it's not one of those skills that I'm really necessarily proud of because in hindsight, it was really kind of a waste of time. All that time I spent debugging these hard to analyze issues was time I could have spent writing, and improving software in other ways. So the value add of Rust is that certainly over traditional systems programming languages is that it saves you from having to do those things. It does have built-in support for WebAssembly. It's as easy as installing an additional module and just building for WebAssembly. If we have time here, I'll go through the motions of doing that, show you how easy it is to build a Rust application targeting WebAssembly. And pretty much every library is just pure Rust library is going to be compatible out of the box. So you can just, add whatever dependencies you want to your app and just know that they'll run in the web browser without any fiddling, which is a really nice thing. On the drawback, if you've heard anything about Rust, you may have heard that it does have a steep learning curve, and that's summed up. I forget who said it, but they said with Rust you get the hangover first. So with other languages, you have fun at first, and then you get the hangover the next day, or whatever the equivalent of the next day is. When you've gone to production or whatever, when you're debugging those difficult issues. With Rust, you tend to get the hangover first, and then it's fun afterwards. That'll give you a sense of it, and that can be a turnoff for some people. It's like, why would I want to go out and to a party and have a miserable time only and then only expect to have the payoff later, and it may not be worth it for some people. It was for me, needless to say, but it's something to consider.
Just a quick question: how does Rust prevent, or how does it minimize race conditions? I guess, like what's inherent in making you do that?
Great question. Let me see. Can I back up here? So there is there are two concepts in Rust. I'm not sure how deep to get into this, but Rust has this concept of traits, which are essentially, you can think of them sort of loosely speaking as interfaces, the equivalent of interfaces in Java, or they're definitely much closer to type classes in Haskell. But it's basically, a trait is something that can be implemented by a type and that can basically add additional functionality to that type, or provide guarantees for polymorphic functions that accept a range of types to guarantee that type will have the features that trait confers. And in particular, to answer your question, Rust has a handful of built-in traits which are known to the compiler. Two of the traits are called send and sync, sync being short for synchronization. And the send and sync traits work together. They're actually automatically implemented by compatible data structures such as mutexes and atomic variables and so on, which and automatically not implemented by data structures that are not thread safe, if that makes sense. And thus, if you try to share data without wrapping it in a thread safe, in other words, send and sync compatible type, then the compiler will not allow that program to compile. So for example, if I just have a data type like a person record and it's got a name and a phone number, and I try to essentially share that between two threads without any additional protection to ensure that, that there's no data races in accessing and mutating that data structure, then the compiler won't let me do that. It'll flat out won't let me do that. It'll say, hey, if I try to send it across, if I try to send it from one thread to another and it doesn't implement send, it won't let me do that. Or if I try to use it from more than one thread and it doesn't implement sync, it won't let me do that either. And the only way to correct that, to make the compiler happy, is to wrap it in a mutex, or say basically convert the fields to atomic variables, for example, or wrap it into some other concurrency control construct like, software transactional memory wrapper or something like that. Does that answer your question?
Yes. Yeah. So
Okay.
basically, the compiler won't even let you compile the code without sort of handling it in some sense in a more atomic kind of way.
Right. And it's important to note that's not just a warning. It's not just an optional thing that, hey, you can't just tell the compiler, get out of my way, I'm going to do it anyway. Actually, technically you can if you use the unsafe keyword, but that's going to be a red flag when you code review. So there are certain specific cases where you actually need to kind of tell the compiler, what you're doing, trust me. But that tends to be when you're interacting with libraries written in other languages like C++. So you don't normally deal with that in pure Rust programming. But the most important thing to note here is that because the compiler is enforcing this is one less thing in code reviews that you need to look out for. And I think that's one of my favorite things about Rust, and part of the reason I pushed it so hard at my last job, which was, and why I'm still using it now, is that it's really especially valuable when you're working in a team with people of mixed skills. You've got some junior developers, you've got some senior ones. I'd rather have my junior developers kind of be arguing with the compiler a little bit more than have to go through their code line by line and look for these types of issues. They're going to have other issues. Rust isn't going to prevent every issue, every possible issue, but I don't have to look for data races when I'm reviewing Rust code. I don't have to look for memory errors. A lot of the stuff that I had to be paranoid about when I was, working together on a team on big C++ projects no longer become an issue. And that goes for Java projects as well, especially when it comes to data races and that sort of thing.
Hey, Joel, Sudeep
Yep.
here.
Yep.
Could you possibly give an example where you would decide that Rust is your technology of choice for building those specific applications?
Yeah, that's just happens to be the topic of my next slide. So let's dive into that. Let me start at the high level, and then I'll try and kind of dig down into what you're asking specifically, because I don't know that this slide necessarily hits it totally on the head. But first, as a general philosophy, you've probably heard the term or the phrase, choose the best tool for the job. I think there's actually something that gets lost sometimes when we say that, which is we also need to consider the team, the tool that's going to be using this tool. In my case here for this project that I'm about to present, the team was just me because it was a hobby project working on in my spare time. So it was a little bit easier, but you have to think about what is the mix of senior and junior developers. What are their strengths and weaknesses? Are they really good at writing code but not so much as debugging? And you've probably heard the old phrase, it takes twice as much skill to debug something as it does to write it. So most of us kind of fall into that category. Another one that I think is not necessarily considered as much as it should be, which is it fun? Does the team think it's fun to use? Are they excited to learn it? So, like I said, my experience at Mersive was some of them were excited, some of them weren't, and so I had to kind of be judicious about deciding, okay, which projects does it actually make sense? Am I going to work on this project, and are the maintainers of this project are they going to consider this? Are they going to be willing to learn this tool if they don't already know it, or if they do know it, do they enjoy using it? And certainly, if you lead a team where everybody is actually having fun, whether it's because of the tools or the culture, or usually it's a combination of all those things, they're going to work longer and harder and get stuff done faster. So I think that's an important point. And for me, Rust is fun, to be frank. For others, it's a nightmare. So if I was working on a team where everybody else disagreed about it, then I certainly wouldn't choose it. But I think your question was a good one, which is, okay, but still, what jobs, what programming challenges, what programs is Rust particularly suited to? I would say, basically, honestly, I think everything that you would have considered using C and C++ for, I think for all new code, unless you've got a big existing code base where C and C++ are still kind of, the dominant factor. If it's a brand new code base and you're writing something from scratch and you feel like you need to be able to optimize memory usage and performance to the nth degree, such as if you're working on traditional systems programming types of things, you're implementing a new video codec, or you're doing some sort of financial trading algorithm that needs to, high frequency trading, and it needs to execute with extremely low latency. And traditionally, you might have chosen C or C++. You should be using Rust, in my opinion, because I think I think Rust basically takes all those advantages of that fine-grained control of performance, plus adds a level of reliability that in practice has never really been achieved, except in very small cases in the C and C++ world. And then the final thing, and if you have a follow-up, Christian, I can get to that, is there are aspects of static typing that I'm a big fan of, that Rust uses to very good effect, as we were talking about before. Catching data races at compile time rather than detecting them more or less at runtime, the way most other languages do it. That reliability, if you're working in the telecom space, which is where I come from, and you basically need that, you need those 9 nines of uptime, and it needs to not just be up, but it needs to work and have predictable performance. That's where this matters. If you're making a shopping cart app, definitely I wouldn't use Rust. I think it'd be overkill. Does that help?
Yeah, perfect. Joel, thank you for that, completely detailed explanation. So, what my biggest takeaway from what you just mentioned is, would it be safe to categorize that we or any particular application development team would consider Rust to be really uh, as the middle layer, or for essentially writing, for example, third-party libraries? And I'm coming from I'm coming from the MVC framework, from more
Okay.
like a client-server technology
Okay.
framework. So I have the front end, I have the back end, and right in the middle, where if I had a specific functions for which I have C++ libraries, if I have written my middle layer to do any kind of business logic and implement that, those can technically be replaced by Rust, based upon the fact that if those were Java specific or C++ specific applications, then Rust is ideally a good candidate to have them right up from the ground up.
I would say so in general, with the only caveat I would add is that, it can be a tough sell to actually rewrite perfectly working code. Like if you've already debugged the heck out of your C++ or your Java code and it works well and it's reliable, don't mess with a good thing, right? It's good, just leave it and let it go. But if you find that it's not reliable, and you think some of the issues that you're running into again and again are reminiscent of what I'm talking about here, that Rust is really good at avoiding, then you could consider rewriting it. And certainly I would say, if you're writing something brand new anyway, and you're trying to choose between Java or C++ or Rust, I would choose Rust. I would definitely say you should choose Rust if you're choosing between C++ and Rust. Whether you're choosing between Java and Rust is kind of a little bit more nuanced, because there's a lot of infrastructure and knowledge around Java that you'd be missing out on, given that Rust is a much newer language with a lot less popularity. But it's something you could consider, especially if your team was excited about it. So
Perfect. Thank you so much, Joel. I really appreciate it. Thank you.
Sure.
Awesome.
Okay, yeah, so I think we can move on here. As a practical matter, if you are writing web applications, in other words, the front end that's going to run in the browser of a single page app, that constrains things a little bit. It has to either compile to WASM or transpile to JavaScript or be JavaScript itself. And you can see some examples here of both those categories. And I just want to keep us moving here. So, but I love this conversation. Yeah, feel free to keep interrupting. I just want to make sure we respect everyone's time here. Okay, so really quickly, I'm not going to spend a lot of time on this slide. This is more for reference here. If you really are like gung-ho about implementing, not just using Rust, but using Rust in the web browser, these are the sorts of technologies that you would look at. This is still, keep in mind that, compared to the world of like React and Angular and TypeScript, this is you're going to be going off into an area where that's a lot less popular. These frameworks are really, they're labors of love, rather than, Facebook doesn't have a giant team working on any of these frameworks the way they have a team working on React, for example. So, and when you go to Stack Overflow, you're going to find millions of questions on React. You're not going to find millions of questions on Sycamore. You'll find a few probably. So keep that in mind. You're going off the beaten path, so to speak, if you embrace the this aspect of Rust, the Rust in the web browser. But briefly, WASM, BindGen, and WebSys, it's basically direct access to browser APIs. So basically, if you just want to write Rust code the same way you would write plain vanilla JavaScript web apps, you can do that. These basically provide well-typed. These are like equivalent, if you're from the TypeScript world, it's equivalent of the typings wrappers for the standard web APIs, web browser APIs. U was one of the original web application frameworks for Rust. It's very reminiscent of Elm or React, if you're familiar with those, based on virtual DOMs, functional reactive model. Seed is another one. There's probably quite a few others. Sycamore and Perseus, if you're familiar with Solid.js in the JavaScript web app world, they're inspired by Solid.js, which seeks to maximize performance by avoiding the overhead of a virtual DOM. And it gives you kind of fine-grained reactivity. If these terms don't really mean much to you, I've got at the end of this presentation, and I'll try and share this somewhere that you guys can get to it. I've got links to it. You can read more about it. Dominator and Moonzoon, I haven't actually played with these, but they actually have a very similar feel and philosophy to Sycamore and Perseus, but they're a little bit more early in development. I think they've got a lot of promise. And by the way, Perseus and Moonzoon basically are based off, like Perseus is based on Sycamore and Moonzoon is based on Dominator. The latter, or the Perseus and Moonzoon, are kind of more full-featured server and client-side frameworks. So the idea is that you can create hybrid web apps where the HTML is partly or entirely rendered on the server side, and then sent down to the client, and then you can essentially hydrate or dehydrate and rehydrate your web application, if you're familiar with that terminology. And then finally, you've got kind of similar to the JavaScript world, where you've got various bundlers that'll bundle up your CSS and your HTML and your code. You've got the equivalent for Rust, which you can look into. I've been using Sycamore and Trunk, but there are other options. Okay, so we're getting down to one of the last slides here. Wanted to not spend too much time on this, but just as a practical example of a web application where the Rust, where the back end and the front end are both implemented in Rust. Tagger is a little hobby project. I told my wife years ago that I would create a web application for equivalent to, say, Google Photos or Apple iPhoto that will allow us to organize our photos and and videos, partly because I'm cheap and I don't want to pay Google the extra storage costs to store, up to terabyte or so of media. Plus, I'm concerned about privacy issues. So Tagger, the idea with Tagger is it's a self-hosted version of one of those tools with a pretty crappy UI, to be honest, but better privacy. So if you're interested in that, you can check it out. Let's see. So technical details. Warp is a popular web framework for Rust. It probably will remind you a little bit about of the Express framework for Node.js. So you basically create routes and define handlers for those routes. Pretty common these days. SQLX and SQLite for storage. SQLX is a really nice library. It will allow you to write queries, SQL queries in your code and actually have them checked at compile time to make sure that, the rows, it'll check, the compile time mechanism will check against your database schema to make sure that your queries actually correspond to that schema, that you didn't misspell a column name, for example, or use the wrong, have your code expect a string when the column type was an integer, that sort of thing. I think, they have similar things like the .NET world has LINQ. I think this is starting to become popular in a lot of languages where you can statically analyze and compare your code with your database schema. So just know that Rust has the same thing too. And then we've got various libraries that, like FFmpeg you may have heard of. This is something I've used for my whole career for transcoding and, minifying media and converting it, that sort of thing. The front end, like I said, I'm using Sycamore. For the UI, use a few libraries behind the scenes. For request is just kind of a friendly async await style wrapper that ultimately, when you compile for WASM, is just using the browser fetch API to do HTTP requests. But it kind of does things like automatically deserializing JavaScript into, or I'm sorry, not JavaScript, JSON into Rust structures and do it checking for errors, making sure the schemas match and everything. So it's got some ergonomic features that are worth playing around with. Just a quick little overview of kind of where this fit in, but in my sort of hobby photo management system. I have a whole architecture diagram for a hobby project. That's kind of how I am. But so my wife and I on our phones, which is where we take most of our pictures, we've got this little tool, third-party tool called SyncThing, which continuously backs up our photo and video library to my home server. Those are in turn periodically backed up to Backblaze. And then, just in case my home server dies, or the SSD goes bad. And then finally, we've got the Tagger server running on my server, serving up the media files and metadata to the Tagger client running in a web browser. We're running out of time here. Sadiq, do you have recommendations? Should we just go to questions here? I can do a quick demo of the app.
I think on our end, I'm okay going over as long as others are. Because this has been a very interesting topic, and also we've been asking questions throughout, so we don't need to do it as formally as have like a official Q&A or anything. So just go for it.
Okay, cool.
Yeah.
Great. Let me, before I do anything else, let me exit out of here. And I just want to, there may be other places I can share this link, but I just want to share this with everybody in the chat. So in case you want to click on some of the links here, anyone, copy link, yes. Gotta wait, get link. There we go, copy link, okay. So there's a link in case you want to look around at that presentation. And then I'm going to switch to sharing my other screen here. Done with that. Let's switch to Zoom. Bear with me here, sorry. Zoom chat. Why is this still full screen? Let me see. Oh yeah, here, I gotcha. Let's see. Stop share, that's what I wanted to do. And share screen, desktop to share. All right, can you guys see my other screen here? You're gonna see some photos pop up here. You're muted if you, okay, great, thank you. Awesome. Okay, so this is just a view. Like I said, I'm not an expert on UI, design or anything like that. So it's actually not super pretty, but it gets the job done. Here you see I'm filtering. Basically I can organize photos by tagging them with various tags, and then I can some of the tags are automatically assigned based on the year. You can see down here at the bottom here we have some malformed years in some of the media items in my library that I haven't cleaned up yet. But you can kind of let's say we want to look at oops, wait, that was public and mountains. So basically I can create essentially and or like Boolean algebra types of queries. So I can say, okay, I'm filtering based on all publicly available images, and now I want to create a subfilter. I want to say public and mountains. And then once I do that, I should see all the publicly visible pictures of mountains that I have in my photo collection. I can click on one of them and arrow through. These are all just photos. Let's look at a video. Let's change that filter. Let's see, we've got a video of my boys playing football or something. We can just keep clicking through. As you can see, pretty much all my photos are of my family, my boys. That's what parents do, is they just take pictures of their boys or kids all day. Let's see, that you can go into selection mode and you can bulk select things and tag them, add additional tags or remove tags. And that's really about it. We can, flip through pages to see older photos. But yeah, pretty bare bones photo browsing app. But yeah, all implemented in Rust, WebAssembly. I'm sure you could implement something that was just as efficient in JavaScript. For me, though, I don't like JavaScript. I like TypeScript better, but it's it has its issues, especially when you're mixing JavaScript and TypeScript libraries together. There's not a real clear boundary in terms of static typing and dynamic typing, and the dynamic typing can seep in. But anyway, I won't go on that rant right now. So Rust just felt like a good choice, and it was pretty ergonomic to implement it in Rust, and I didn't have any worries about reliability or performance. So that's that. So with that, we can go into questions. We can browse the code if you're interested in that. I don't know how interesting that is. I was going to do a little live coding and make some changes, but I don't know that we have time for that. So I think we'll just, I'll switch over to the website here.
Joe, we could do.
How large is the code base?
Yeah, good question. Let's see if GitHub can tell us that. Let's go to here. Let's see, insights. Does insights tell us? Anybody know GitHub real well? Does it tell us how many lines of code there are and that sort of? Oh, I guess it does on the little summary. Well, it's 99% Rust. That doesn't help that much. Wait, can we click on that? No, that doesn't. Yeah, let me just one sec here. This might take too long. I was going to install a little line of code thing. We can come back to that. While we're waiting for that, any other questions?
I just had a quick comment, Joe. We could also do like a live, I guess, maybe in a couple months, do more of an interactive coding thing as well, because this is definitely worth a session where you run that through.
Yeah. So this is the code here you see over on the left. I've got some CSS up right on the right here. But let's see, this is the tag menu. When you saw that menu drop down where I could browse by year and choose mountains and public and sort of that sort of thing. It's a kind of a recursive hierarchical menu here that's implemented here. You can there's a link to this repo in the presentation if you want to look at it in detail, but you can kind of get a flavor of the language here. Let's take a look at something Sycamore specific. So if you're familiar with JSX in the React world, where you can embed HTML in, oh, sorry, my compile time is affecting the meeting quality. Let's see. Hopefully you can still hear me and see me.
Yeah, it's fine. It's
okay, good. So if you're familiar with JSX, the idea is that you can embed HTML inline in your JavaScript code or TypeScript code. It's the same idea here. Like we have little snippets. This doesn't look like HTML, but it's essentially isomorphic to HTML. So you've got a list tag and an icon tag and so on, and then an embedded component that we defined in our Rust code for the submenu here. And then of course you've got, classes which are conditionally defined here. And we've got an on-click handler, which just invokes a lambda that I defined earlier. So shouldn't be too, if you're familiar with React or something, or pretty much any modern JavaScript web framework, it'll look pretty similar. And feel, modulo the difference in language, and even if you're familiar with TypeScript, the syntax will look pretty similar in terms of like how there's you specify type arguments and generics and that sort of thing.
How is the package management ecosystem and the general community around Rust, like benchmarking against NPM, which is a dumpster fire and a security nightmare right now, right? Like,
yes, yeah, great question. So there's a mixed bag there, to be honest. The Rust community is, of course, a lot smaller than the Node and JavaScript community, and so it benefits from that right now. In that you've got a lot of dedicated, honest, well-meaning people contributing to the Cargo ecosystem, Cargo being the package manager for Rust. Let's just one sec here while I'm, oh yeah, so here to answer the earlier question about how much code there is, that'll give you if you could see that in the lower right corner, that'll give you an idea. So, however, and this has been an area of controversy, there isn't a lot of security around, or like there's no moderation of like packages or curation of packages the way we, a lot of people are clamoring for in the Node NPM world. Basically anybody can upload a package. Some people will squat on commonly used names and not actually do anything with the package. So there are some problems there. So I think the key to kind of being a productive Rust developer and working within the Cargo ecosystem is you kind of have to learn which packages are really reputable and useful, and well known, and there are tools out there like Cargo Crev, which provide essentially a web of trust around packages to basically say, hey, 12 people that I trust also trust this package, so I can probably use it, that sort of thing. So but that hasn't really become mainstream. So I guess to answer the question, the short version is, unfortunately, if changes aren't made to the Cargo ecosystem, as the Rust community grows, it may start to turn into that dumpster fire. I hate to say it, but the tool itself is not, and the people who maintain crates.io are not necessarily making it a priority to avoid those sorts of issues.
So real quick follow on to that.
Yeah.
On the JavaScript and the C# side of the world, we use a lot of dependency management techniques. We use GitLab, which is great because it has a whole bunch of this built in, frankly.
Got it.
Is there similar dependency management tooling or vulnerability-based tooling for Rust? In other words, literally I check in code with a new package and it goes out and says, hey, there's no known vulnerabilities for this package.
Right. Yeah, that's a great question. So I think GitHub these days, yeah, I don't have a definitive answer to that. I actually haven't seen GitHub like warn me, hey, you're using an out-of-date package that has security vulnerabilities. Part of that may be because I tend to be really regular about updating my dependencies anyway, just because it's as easy as it is in NPM for the most part, assuming the API isn't changing too much. Plus, of course, Rust being a statically typed language, and using and having semantic versioning, be taken very seriously. You don't tend to have surprise, breakages from a dependency update. But yeah, that's something that I can't answer off the top of my head. I would recommend you kind of do a Google search for I'm not sure what the keywords are there, but like Rust, just using GitHub as an example.
We use also SonarQube on our end, by the way, and we know that it does do Rust scanning along those lines. So there is some tooling out there if you're willing to pay the money. I guess my question was more like what's out of the box, and
exactly.
I think you've kind of answered that question. So
and I want to emphasize that I'm speaking from a perspective of ignorance. For my hobby projects, I haven't been too concerned with it. Maybe I should be more concerned. When I was working at Mersive, we use SonarQube as well. So I should have mentioned that to start with. So I never went looking necessarily for an open or out of the box version, which isn't to say that it doesn't exist, but it hasn't passed my radar. So
nope. Great answer. Thank you.
Yeah. Any other questions? I know we're a little over here. I've got time, but so I can stay here as long as you guys want, but I don't want to waste your time either.
Hey, Joel, just wanted to thank you. This is by far such a beautiful and detailed discussion. I really want to take a moment to thank you for this wonderful, wonderful presentation again.
Well, it's been my pleasure. You're welcome, for sure. Let's see. I'm going to stop sharing.
Same here, Joel. I think, your ability to get the subject matter across is amazing. So thank you. I'm definitely going to reconnect offline to see if we can do something maybe a bit more immersive in the future. But yeah, this was great. Any other questions, anyone?
Sadik, once again, thank you for getting this together. I've really started looking forward to these sessions. I've been waiting for this session since last week.
Oh, good to hear. Thanks everyone. And we'll continue to do these and probably start doing deeper dive sessions into some of the really popular programming languages and the like. So Rust for sure is among those, but also some of the other programming languages, like Golang and things like that as well. All right. Thank you, everybody, and we'll catch up soon. I'm going to stop the recording now. Thank you.
Thank you all. Thank you, Joel.
Thank you.
Yep.
Thank you,
Thank you, guys.
Right.
Thank you, guys.